Mark, thank you very much for your discussion. I'm happy to introduce the second of our two discussants, Professor Andy Gelman from Columbia University, where he holds appointments in the Department of Statistics and the Department of Political Science and directs the Applied Statistics Center. Professor Gelman received his PhD in statistics from Harvard University. He has worked in a wide range of applied research topics, including voting and polling in elections, legal statistics, public health, and economics, to just name a few. Professor Gelman has done extensive work in many statistical methodological areas, including survey design and estimation, social network structure, Bayesian statistics, and computation and graphics. He's authored numerous peer-reviewed publications in very good statistical and subject area journals, and he has co-authored 6 books. Professor Gelman is a fellow of the American Statistical Association and the Institute of Mathematical Statistics, and it is my honor to present to you Professor Andrew Gelman.
So it's a pleasure to be here. I grew up in the DC area, and my parents worked for the government, and my mother actually was involved in data collection at the Bureau of Labor Statistics. She was an economist, not in a supervisory role, but she would actually call up companies to check on the statistics, their employment numbers, and things like that. So I always consider it a great privilege to speak in any government building, especially when it's beautiful as that. Earlier, Dr. Graubart mentioned hidden, hard-to-reach, and marginalized populations, and I'm very interested in that as a political scientist because I study voters. And you're supposed to laugh. Voters are hidden, hard-to-reach, and marginalized. And actually, often what we're interested in is not just hard-to-reach groups, but how they relate to the larger society. And you saw that in Steve's talk, of course, with the transmission of disease. So I want to start with an example. This person here, Senator Rob Portman, co-sponsored the Defense of Marriage Act, voted for a measure prohibiting same-sex couples from adopting children. He had a hostile record on gay rights. Students protested him. He believed that marriage was a sacred bond between one man and one woman until he had a change of heart. His son was gay. He's come to the conclusion that marriage is something we should allow people to do and have a joyous ability that he's had for over 26 years. So this is an example of network transmission. That actually wasn't just words of laughing. That was actually serious. And Dick Cheney also having a similar network effect. We're interested in groups not merely in themselves, but in what we call their penumbra, the number of people who are in the family or friends or acquaintanceship of the group. And we wanted to study this, so we did a survey. We surveyed 3,000 people. We did a panel designing. I'm not going to talk about the panel aspect today, but we asked people questions like how many close family members, how many close friends, how many people do you know of different groups, and then we lined these up with attitude questions. And I'll just show you a little bit of what we found. These were the 14 groups. In each group, active military, immigrants to the United States in the past 5 years, etc. The red zone represents the proportion of the population who's in the group based on publicly available data. The very light quarter circle represents the entire population, and the dark quarter circles inside represent the number of people in the population based on their survey who know at least one family member or close friend, or anybody in that group. And as you can see, different groups with the same size have different numbers. So immigrants and gays and lesbians have very close to the same size group in the population, but the penumbra of gay and lesbians is much larger than the penumbra of immigrants. And of course, we've been seeing immigrants a lot in the news lately, perhaps not benefiting from having such a large penumbra. Now I want to talk about a little bit about network sampling. Sometimes you do network sampling because you want to. Sometimes you do network sampling because you have to. We can have network structure in the sampling and network structure in the population. And Steve talked a lot about network structure in the population, whereas Mark talked more about network sampling in the sample, network acid structure in the sample. Now, when you use network sampling to learn about the general population, often you'd like to use simple random sample, but you can't. And that's the example in some of these respondent-driven sampling examples. Now there is a solution, a model-based solution to these problems, which is to post-stratify. You can take your sample and adjust to make the sample match the population. Now if you do a network sample, put it this way, the network sample actually looks a bit like this picture. It's not, if you look at this picture carefully, you realize it doesn't look like anything like a random sample at all. It's actually 4 people out maybe standing next to each other. So your network sample shouldn't look that bad, but it's not going to be completely representative of the population. But we can adjust. And one thing we've looked at is adjusting for variables that, you want to adjust for variables that matter in the sampling and also matter in the population. And that's true under any model or design-based approach. So in this case, 2 variable, can you hear, is this an echoing all over the place? It's okay? Can you hear it? So 2 variables that are very natural to adjust on are the degree of the individuals, or the gregariousness, that how connected individuals are, and their distance from the starting point of the sample. So if you imagine that when we take a network sample, we can record or estimate the degree of gregariousness of each person. We can also have a measure of how far he or she is from the starting point of their sample by just how many links it took to get to that person. Then we can use statistical methods to estimate the sizes of these groups in the population and adjust. And we just use a formula like this, we post-stratify. Now in this case, it's somewhat of a challenge because the post-stratification cells are defined based on all your usual demographics, plus gregariousness and plus distance from the starting point, which means you don't actually know the big ends, they have to be estimated also. But that can be done, I'm not too concerned about that. So that's a hard problem, but I think we can deal with it. It's not that hard. Learning about network structure itself, though, can be a challenge. And here, I have the slides, so I'll just explain here just briefly. That when we're doing post-stratification, we'll have a large number of cells. As I said, the logic of survey adjustment is that as our surveys become worse and worse, we need to adjust for more and more variables. Now, traditionally, we adjust by rating, just like these characters here are doing. But there's a limit to how effective rating can be because of granularity, and hence we use multi-level regression. Anyway, that's sort of aside from that. What's the fundamental problem of network sampling? Here I'm not actually referring to the network of Lilliputians. Rather, I'm referring to the fact that you can't really create little 3-inch tall people that can act like people, right? Like, it doesn't scale that way. And similarly with networks, a small sample of a network doesn't look like the network itself. And in this way, I just have to say, we've been very spoiled. So if you work with atomistic data structures, a small sample looks like a little bit of the population. It's just a little smaller. A small sample of a network doesn't look like that. And this brings me to an interesting paradox of literature, which is Charles Dickens. Charles Dickens, like Tom Wolfe in recent years, was known for writing novels that reconstructed the entire society in miniature. And But Dickens is also notorious for his coincidences. So I don't know if you remember these books from when you were assigned them in 10th grade or whatever. But Dickens' characters seem very real, but they're always like running into each other on the street and interacting in strange ways. And it turns out that somebody is somebody else's uncle, and nobody else, nobody realized it. Now, how could this be? My contention is that Dickens was doing his best to solve an unsolvable problem, which is to reproduce a network given a small sample. What is a representative sample of a network? If I take a network of 1 million Londoners and I take 100 people from that network, and I look at the connectedness of that random sample of 100 people, it's going to look very diffuse and atomized. Because there's lots of people, like here's somebody here and here's somebody there, and they're actually connected through 2 intermediate people, but in only 100 that you get, you don't see that. Right? So the sample of the network you see doesn't look like a miniature version of the network. It looks no more than a sample of human cells would look like a little person. Right? So in order to construct something that had the appropriate network properties, Dickens had to artificially fill in the network. In a sense, he had like the Impressionists, right? So the Impressionists paint, and their paintings look more real than a photograph in a certain way, because they're capturing certain aspects of reality. They're painting sort of what is actually underlying happening. Similarly with Dickens, for him to construct the network required him to be truer than literal truth. And so he needed to make those connections. But really the point is that it's an impossible problem. There is no more, you can't take the globe and make a flat map that matches the globe. You have to make compromises. Similarly when reproducing a network. But we're not used to thinking that way, because if we have an atomized sample, we actually can create a sample that's representative of the population. But with networks, we can't. But it's not all bad news, because we can also use network structure in order to learn more from non-network samples. So certain people are hard to survey, like people in prison, people in other oppressive institutional settings. But how do you survey these people? Well, actually, you do a survey and ask someone, how many prisoners do you know? Well, that simple question, how many prisoners do you know, tells us a lot about the social network of prisoners. It tells us who knows the prisoners, so we can learn a lot. And of course, then you can ask people about the prisoners they know. So I think what we have to do, and I know what you are doing in the federal statistical agencies, is that you have to go beyond the traditional individualistic approach to survey sampling. I mean, in survey sampling is traditionally that way. It's traditionally like, it's as if the entire field of survey sampling was invented by a couple of economists in Chicago or something, right? It's so individualistic. Like you ask a person about themselves. Maybe you ask them about their family. That's the most, right? You could do. It's like Margaret Thatcher is designing these surveys or something. But really, there is such a thing as society, and we can ask people all sorts of things. And every once in a while, I get done to teach me this special thing, like this special module. We ask GSS. We ask you about 4 people you know, whatever. But I think that's a mistake. We really have to. We're interested in networks, and we also have great opportunities that we can learn about these populations in this way. I have another idea which I call fractal sampling, and I was actually struggling to find the right image. This isn't fractal. It's not really the right image. This is another one. This wasn't the right image either. This was the best I could find. This is actually some neurons. What I'm thinking here is, when you do a survey, you want to learn about things at all levels. So if you think about politics, you want to learn about what's happening at the national level. So you want a national representative sample. But you also want to know what's happening at the state level, and the city level, and even the block level, the community level. But you can't take a sample of 10,000 Americans and get any detail on the community level. Because remember Charles Dickens, blah, 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 10,000 Americans will be all over the place. So I think we need to do a fractal sample, where it's nationally representative, because we get data from most of the 50 states, but then within certain states, we actually drill down, we get more detail in certain cities. And then in some sampled cities, we get more detail, and in some neighborhoods. So the actual sample is a cluster sample, but of a special multi-stage cluster sample, but of a special form. And again, the usual way we think of cluster sampling is we wanted to do a simple random sample, but we couldn't afford to parachute interviewers all over the country, so we did a cluster sample. But I want to think of it as a feature, not a bug. That we want a cluster sample because we're actually interested in certain network aspects of society. We can similarly do fractal sampling in time. So think about things like food consumption, like dietary surveys. Did you eat fish yesterday? Well, we can do a survey once a month. Did you eat fish today? Did you eat fish today? You might be interested in knowing if there's a certain fish consumption, whether people are binging on fish or just eating it every Friday or whatever. So it probably makes sense to survey some people 2 or 3 days in a row. Other people survey them a few years apart to see how consumption is changing a year later. And I think that really fractal sampling is the only way to do this. And so in conclusion, I think that I really loved Steve's talk, and like I said, I really loved Mark's talk, but it was shorter, so I really liked Mark's talk. In that, I really think that we've been living and working in an artificial world, so a world we might call the world of atomistic sampling. And I think moving to the real world of networks and fractals is challenging but has real payoffs. As Steve has shown in his research, we can use statistical modeling tools to learn from network samples and also about network structure.